Okay, so we're going to go ahead and look at quantitative data and how to graph quantitative data. And we're going to look at two versions today, and then we're going to look at the shape of the graph, and we're going to use that to help us describe what's happening along with our measures of center, which is our mean and median, and we'll also talk about our measure of center as a mode from our graph today. And we'll talk about spread, which is standard deviation, IQR, and then we're going to start looking at range also, which is easy to spot from a graph. And then also, are there any possible outliers? Because you can use the graph to kind of see, wow, that number looks pretty far off, so maybe I should go ahead and test for outliers. So our first method is graphing with a dot plot. So the first thing you want to do with the dot plot is go ahead and make a number line. So you're going to have your little number line. And when you're making a number line, you want to make sure that you're going to label your number line. And so as you're doing your numbers on your number line, you want to just write down what are those numbers representing. So that way when they look at it, they understand what's happening with those values. You plot a dot for each number above the correct number on the number line, and then we look at the distribution and kind of look at the shape of it, and we'll talk about the shapes of the distributions in just a little bit. So please remember, dot plots are really good for small to medium sets of data because you don't want to be drawing 200 dots. It just doesn't really make sense. So our set of data looks at the number of family members for 10 residents from the 2000 census. And so when we're looking at our number line, we're probably going to want to start with the number 1 because that's our lowest number, and then go up to the number 6 because that's our highest. And then this represents the number of family members, so we label that appropriately. And then we're going to go ahead and grab a little tool to help us make a dot. And we're going to go ahead and put a dot for each number in there. So I'm going to put a dot for 2, and then 6, and then 2 again, and then 4, and then 3, and then 3, and then 4, and 4 again, and then the number 1, and then the number 4. And so that gives us an idea. We can look closely at that and just kind of see how that lays out, how that spreads out, where our peaks are. And our peaks are also known as our mode. Just the one that occurs the most often. And as we get to different types of graphs, we won't have just a mode, but we'll have a modal group, depending on how the graph is made. And so that's our dot plot. Our next graph is a stem plot. Also best used for small to medium set of data. Our stem plots are separated into two parts of the number. There's the stem, and then there's the leaf. The stem is going to include all the digits but the very last digit, and that last digit is going to be your leaf. So if I have a number like 123.24, the 123.2, that's our stem, but the 4 at the end would be our leaf. And then you can have like different versions of that, but that's the main idea. Now your stems are going to be in a vertical column with the smallest number at top. You draw a vertical line to the right of that column. You never skip stems, even if there isn't a value there for that. If there's no leaf there, you have to have the original stem there. And then you write each leaf in the row to the right. The numbers have to go in increasing order. And then you always provide a key to explain how to read the value. So for example, we have the heights of male and female students. So here's our male students, here's our female students. And we have a stem plot for the male heights. So here's our stems, 15, 16, 17, and 18. And then we have our vertical line, and then we have our leaves off to the side. And you can tell from our leaves that they go in increasing order. So 1, 4, 7, 9, 2, 3, 5, 5, 7, 9, so on and so forth. And then over here is that key, which is telling us that 15/1 really represents the number 151. Now you'll get cases where 15/1 may be 15,100,000. And so it's really important that you have a key to say, this represents this value. Because if you're not careful, you're not really understanding what those numbers are representing and in context. So it's a male who's 151 centimeters tall because we only graph the data for males. Okay, so we have other special cases of stem plots. We have what we call the split stem. And so it breaks up our stem plot because typically if we have less than 5 stems, it's not a wide enough graph to really see what's happening with the distribution. Or if we have a really long set of leaves, then we'll break those up. And so what ends up happening, so like right here, we have 15 broken up into 2 spots. So we split that stem of 15. And so the leaves for 0 through 4 will go in the first one, and the leaves for 5 through 9 will go in the second one. And that's how we break it up. And so it allows us to see a little bit more that shape that's occurring, what that distribution's truly looking like. So it spreads it out for us. Now our last type is a back-to-back stem plot. And so this is where we may be taking our data and breaking it up between 2 categories like male and female. So on this right-hand side, we have the male stem plot, and on this left-hand side, we have the female stem plot. So we could see the differences between those distributions, and we could see what's happening. And it allows us to compare so much better. And remember, when we're comparing distributions, we're always using words like males have a greater spread than females. And you can tell this from the stem plot because look how wide that is. And where females are all really bunched up right here, so they're not as spread apart. So males have a larger spread than females. And then you could actually go through and you could find your median from here. So 1. And figure out that your median was like 167. So you can kind of go through and find a median this way. It's a little bit more complicated because you've got to make sure you're keeping straight, that you're taking off from the ends. But it allows you to find a measure of center, and then you can compare those two. Okay, how to examine a distribution. This is probably the most important thing that we're going to be talking about. And our first thing that we need to talk about is the shape. Looking at the shape, because we haven't talked about this yet. So we have, most of our distributions are going to be what we call unimodal, meaning that there's one main peak. Now when we break it up on unimodal, we've got several different things that we're going to be looking at. Our first thing is symmetrical. So our peak is in the middle, it might be kind of mound shaped, it's even on both sides. We've also have a skewed right, which means your peak is to the left, but you have a tail to the right, and then you have a skewed left, which is the opposite way. So let me show you what that's going to look like. So when we're looking at this, a symmetric might look kind of mound-shaped. There's one peak, it looks pretty even on both sides. That's our symmetrical. And then we have skewed right. So that means our peak is to the left, but we have kind of a tail to the right. And so this is a right skewed distribution. And then we also have most of our values to the right, a tail to the left. That's our left skewed distribution. So wherever the tail is, that's how we name the distribution. Now we do have other ones like the bimodal, which would have 2 peaks. Multimodal has multi-peaks. And they don't all, the peaks don't always have to be the same, but if you have groupings that have pretty tall and pretty similar peaks to each other, those would be the multimodal or the bimodal. And then of course we have the uniform, which is one that pops up and that we'll deal with, where it's pretty much flat. They're all pretty much the same value or really close to that, and that's our uniform. Okay, so that's the new one. Now, our old one that we've done that we're just still seeing is what is our center. And so we're now starting to see, okay, where's our peak at? And with some of ours, like with the stem plots, instead of having a mode, we might actually have a modal group. And so with the modal group, we're actually going to look back here really quick at our stem plot here. If we look at the females, because this has the most leaves in it, this is our modal group. So our 165 to 169, that's the modal group. It has the most values in there. And we probably actually have a mode too, but when we're looking at a graph, we're going to look for those peaks, and the peaks would be a modal group. And then we can calculate our median. And one thing that I wanted to talk about with the median from a graph is that you're looking for equal areas. So at what spot can I draw a line and I have equal area on this side and equal area on this side? And that's our median. For our mean, we're looking for that balancing point. And so the longer tail you have, the farther out your mean's going to be from that median, from that 50% area. Okay, our next one is spread. We've talked about this one before also. Spread, we now have our range, which is highest minus lowest, which isn't a very good way of measuring spread, but it's a way. We've got our interquartile range, which we've talked about, and our standard deviation. And I kind of hit on in class about how spread is also known as variability, and we want less variability. It makes it easier to predict information if we have less variability. It makes our predictions more reliable if we have less variability. And then of course we have the outliers. So our extreme values, and we can find those by that 1.5 IQR rule. So what we're going to go ahead and do is we're going to look at the shape of these distributions. Now you can do stuff with the center and all that, but because we have a limited amount of time for our video, I really just wanted to hit on shape because that's our newest thing. So with shape, what I like to do is I like to draw what we call kind of like a density curve. It's just kind of curving around, getting an idea of that shape. And it just makes it easier for me to kind of decide in my head what's happening there. And this is pretty, it's a pretty flat. There's no big peaks or anything happening. So I would call this a uniform distribution. Now with a uniform distribution, typically our center is going to be right in the center of that. So you can kind of measure out and say, okay, right about here, right around 82 or so is my center. And it makes it easier that way when it's uniform. Now if I look at my next one, if I kind of draw a curve, now this isn't a true density curve, but it gives you the idea of how density curves work. And it looks pretty even. We've got a nice peak there in the center, and it's a little less values on this side, but overall, it is pretty symmetrical. Now, something else that I wanted to point out here was these little dots out here. Those look like extreme values. They're pretty far away from my group. So these are what I'd call possible outliers. And when we see that on a graph, that tells us, hello, we need to test for outliers. Should be a big smack in the face that there's possible outliers there and that we should definitely be testing for that. Okay, so let's look at our next one as I kind of draw my little curve, get an idea of what's going on here. Definitely a peak to the left and a tail to the right. Now remember, we name these based on where our tail is. Our tail's on the right-hand side, so it's a right skewed distribution. Now with a right skewed distribution, remember how I kind of said that you can kind of estimate where your median is? Well, when I'm looking under this, I'm wanting my areas to be about even. So if I measure right around here, that might be my median. If I could say this is about the same area as that, that would make it my median. Now for mean, we're looking for a balance point. So now I'm looking at, well, because this is so heavy on this side, I need something a little bit more over here to balance it out. And so that becomes our mean. And so then we start seeing differences between mean and median with these skewed distributions, where with a symmetrical distribution, they should be about the same value. They should be right about there at my mode, about that at the peak. And so that's where we're starting to look at what's the shape, so what measure of center is going to be best, and all of that information. Okay, so moving on to our last one, kind of drawing an idea of a curve. Peak is definitely to the right, tail is definitely to the left. So this would be a left skewed distribution. Okay, so in class we're going to practice looking at the graphs, deciding what shape it is, doing some comparisons. And tomorrow we're going to go ahead and look at 2 more types of graphs.